Hi, it's Jan Beta, and guess what time of the year it is? You guessed it, it's Tandy. And what Tandy means is that there's basically a collaboration of YouTubers, international YouTubers, dedicating this month of September to the Radio Shack Tandy machines, be it calculators, be it word processors, be it, like I do, home computers or microcomputers. My part in this is going to be working on this TRS-80, which is Model 1 Level 2, I believe, if I'm not mistaken. I don't know anything about Radio Shack stuff or Tandy stuff, because these things were not very popular here in Germany. And actually we got very, very lucky to find this at all on eBay, and then for a reasonable price. Unknown condition, doesn't come with any peripherals, no power supply. It has some dents and cracks and things like that, but overall it looks in acceptable condition. I'm going to have to do quite a lot to make this actually work, if I manage to make this work, that is, which I hope, of course. Before we dig deeper into this, let me take a couple of seconds to thank my sponsor for this video, PCBWay, who are a premium manufacturer of prototype PCBs and larger scale projects. If you have any circuit boards to manufacture, I highly recommend checking them out. They offer premium quality for very reasonable prices and offer excellent service. Yeah, the first obvious step is to take a look inside this machine and see if everything's in place, if there are any obvious like burnt components or anything like that. It has been well used and loved, it seems, because you can tell by the paint rubbing off here. And interestingly, underneath the paint doesn't look too dissimilar from the color the C64 bread bins are in. I'm probably also going to build a power supply in this episode, and I'm probably also going to have to build a video cable, and yeah, we'll see. I'm just diving right into this, and I'm going to take you with me on this journey and hope you enjoy it. Hope this is going to be enjoyable for everyone. I'm quite excited because I've never seen one of these, and this should be like nearly exactly my age, I think. I think they were first released in 1977 and I'm born in 78, so this might very well be my age. Or even older. Definitely the oldest computer I have in the lab here. Okay, let's see, let's open this up. And I'm going to be reasonably careful with this because it is, at least here, it is a relatively rare machine. And as I said, quite old and might be really, really brittle. There seem to be more screw holes. There's actually only 2 screws in here, so we might have to put some additional screws in the middle screw holes here. Oh, these are long screws, it seems. Okay. Oh yeah, look at that. It is the case color and shape is quite similar to the Commodore Max, actually, which was released after this was released. Actually, the silver and the black look pretty similar. So this should now just lift up. Yeah, it does. So it seems I was quite spot on with the age of these things. Got it from the smell. This was produced in August 1978. I was conceived in July 78. So this is a month younger than me, roughly. Wow. So here we are. Just going to use my wrist strap here, my ESD protective wrist strap. This actually folds over, I think. There's a flimsy ribbon cable here. Wow, these are like the standoffs for the keyboard. Keyboard matrix. This is just stuck on here, the numpad. Wow. So here's the keyboard, and it's a single-sided PCB, obviously. And this numpad is just like, this is like a plastic clip that connects the two. So that's easy to dislocate, I guess. I think I want to, this is a flimsy ribbon kind of thing, flat flex, not very flexible anymore. So that's probably, it looks alright actually, maybe it's still good. But I've seen many people just replacing this with like a cable from an old IDE hard disk or something like that. And here's the main board, which is upside down. And these are like, this is still elastic actually. And these are hardened, so this was like probably some rubbery stuff originally. These are completely solid. Interesting. Some like plastic degraded over the years. These are still almost feel like rubber, but probably some sort of silicone. Let's try and like angle this. I guess we could just flip it like this. Yeah, there we go. It actually doesn't look too bad to me. There's some Bosch wires which I think might just be factory. These are the RAM chips which might have been replaced at some point. They are the 4116 RAM chips, dynamic RAM chips, which are pretty prone to failure actually. Huge capacitors here because the power supply basically provides AC voltage and a half rectified DC voltage, which I think is then smoothed out the rest of it on board here. And the chips are from 78 actually, yeah. There's some really peculiar things here. This socket, this is like a an extension for the socket which goes to the other side of the board where there is the, I think that's the level 2 upgrade actually, which has a new ROM. That means you could do a little bit more with the machine. Lots and lots of 74 logic chips in here that could break potentially, so yeah, we're going to have to watch out for that. There's a lot of chips compared to the later systems, and considering what this can do. Not many custom chips to speak of, at least I can't see any. And yeah, this is our Z80 processor. Yeah, here we go. It's an original Zilog Z80 from 24th week of 78. I think this must be the oldest processor that I own now. Hope it still works actually. But usually these are relatively sturdy. What I'm worried about the most, which are the parts that might be broken in this machine, the RAM chips, which I kind of suspect that they have been replaced at some point, and the logic chips. There's so many logic chips. This would be pretty painful to troubleshoot, although there's really good schematics and really good service manuals out there that you can download. I'm going to link some stuff in the description that I can find. And here's the little expansion board that I think literally is just, it's just stuck on here with some double-sided foam kind of stuff. Wow, okay, that's a bit nasty. But yeah, otherwise it looks pretty good actually. These are just masked ROM chips, I think, for the level 2 upgrade. Do they have different numbers? Yeah, they do. The middle number changes. It's like 1, 2, 3. And a little 74 LS42 actually, from 78. That's your level 2, which literally sits on another level. I was kind of hoping there would be more socketed chips in here. Yeah, but as far as I can see, I can't see any burnt components or such, so it might just still be good. It might just be a good idea to just try this. So I'm just going to measure the transistors for any shorts, dead shorts. Which there aren't, which is good. Okay. All seems good. Just going to remove some of the crust here. By the way, I hope you check out the other participants as well. because some of the creme de la creme of retro YouTube is gathering for this. Yeah, I guess maybe we should make a power supply. Maybe that's what's next. So as for the power supply, there's actually, that's quite a strange one. The original power supply for the TRS-80, we actually need 14 volts AC, or like 15 to 17 volts AC, and 19.8 volts DC, which is like a half rectified voltage on the original power supply. So we don't have to get these voltages completely spot on, so there's quite some play that we can use. And we basically, the original power supply basically consists of one transformer that has two different secondary windings and a center tap that is used as the reference. And because of these voltages being so different, we are going to work around that and use two transformers and build something like this, which is a design by Dean Baer, who is, I think you can also buy these pre-made. They are pretty high power output. They are designed to power the expansion, which I probably never have, so I'm just going to build something with smaller transformers that don't output as much power. I think he uses 30 VA toroidal transformers with the center tap. I'm just going to use regular transformers that are a lot cheaper. These cost $30 each, so that's probably not quite worth it if you just want to power a standalone TRS-80 unit. So I'm going to build this power supply with smaller transformers. I'm going to have a rectifier, and I'm going to have two transformers, one for the AC, one for the DC. I'm going to add a little LED, I guess. Yeah. And we're going to have a 5-pin DIN plug. So here's our voltages on the DIN plug: 15 to 17 volts AC, 19 to 21 volts DC. AC is 1 amp rated, the DC is 350 milliamps rated. Okay, so we're going to be fine with the transformers I have. So I'm just going to place the transformers with the AC sides. I have this 7.5 volts center tap. This is dual 7.5, so you get, if you take the outer contacts, you get 15 volts, which we are going to use for the AC supply, which is going to be higher if this is not fully loaded, which it won't be, because this is 10 VA. This is quite 18 VA, 6 volts, dual transformer. So this is going to be used for the DC. I marked it with DC. We are going to have the DC. Yeah, I'm just going to use some Perfboard and place these. So I managed to get my two transformers on there, and I already put a bridge rectifier, which is a KBPC604 from Diotech. In this case, you can use, I guess, anything that can take the voltage and the amperage you need for this purpose. So this, I think, is rated at 400 volts, 6 amps or something, which is, of course, plenty for this use case. Yeah, we are also going to add a capacitor. I'm just going to put one in here, 1000 microfarad capacitor. I'm just going by the specs from the Dean Bear power supply, more or less. So yeah, we're going to put that on there, and we are going to add a fuse. I think that's going to be on the outside of this nice little case that I have here. I'm going to link all the components in the description that I can find links to, and I'm also going to link to the PDF of the schematic I'm using. So this actually goes relatively well. I'm just making like a circuit board myself by using component legs and solder to make these traces, and I marked the primary and secondary circuit, don't get those confused. I might actually add like a little cutout. I don't think it's necessary because there are many little gaps between these, but I might just get rid of some of the material here so we don't risk shorting the primary side to the secondary side, which this is the main side of the transformers and this is the secondary side. So yeah, I added the transformers, I added the rectifier, I added a capacitor, I added a 1K ohms resistor for the LED that I'm going to add in the case, and yeah, I'm going to wire that up as well. So I'm actually waiting for some screw terminals that I ordered because I didn't have them in stock, that I can add to the circuit board to make the connections to the power inlet and the power out of the power supply. This is going to be. So far I'm pretty pleased. You can work, I guess it doesn't matter much. I'm a bit sloppy here. I'm going to check everything for shorts. I connected the center tabs actually, and I'm going to have to connect those as well for both secondaries of the transformers, because I think both of those are going to be connected to ground. So I have all the connections made. Connected these little screw terminals to connect the input voltage here, which is our mains voltage. DC out, I tried to mark that with red for positive. Black is the ground. And these are the two sides of the AC. Okay, so we have to work on the bottom case first, I guess. So we have to... This is one of the BOPLA cases that I used previously. Same brand, different size. This is absolutely huge. So yeah, what we are going to have to do is to make sure where everything goes. So on one side of the case, we only need the cable to come out, which supplies our voltages. On the other side, I think I want to put the mains input and the switch on the same side, so it's clear where the mains side is. And yeah, we should put the LED next to the switch, I guess. So actually we need a switch, a fuse, and this on one side, and on the other side we only need the cable that comes out that supplies the computer with power. Okay. That's gonna be fun. Let's try and sketch that out, actually. So I'm going to use masking tape to have something to draw on, basically. Okay, so here's what I came up with. I'm going to put the switch here, the IEC socket here, fuse holder, which I'm going to use one of these round ones that I used before. And that can go here. Okay. Okay, time to connect the fuse, power switch, etc. things. Yeah, of course, power comes in here. We go through the switch, through the fuse with the live wire, and we go directly to the circuit board with the neutral wire. We're going to use some heat shrink tubing, and I'm just going to solder the connections on using some cable I salvaged from power cables. And for the LED, the power LED, I'm just soldering a 1 kilo ohm resistor to the cathode here. In this case, you can solder it to whichever leg you like, just to bring down the current going through the LED. And I'm just connecting this, yeah, basically to the DC output on the capacitor, I guess. So our smoothed DC output. And the 1K resistor should be enough to limit both the current and the voltage to an extent that the LED can cope with. And obviously I'm also adding some heat shrink tubing to the LED legs so they don't short out anything. And I just decided I want to crimp on a little 3-pin connector to the LED, basically replicating the Commodore 64 and other Commodore systems LED connections, where you can't reverse the connector because there is 3 pins and 2. The middle pin is ground or positive, and the 2 outer pins are the other polarities. So that's going to be really cool. Putting this in here. And the center shall be the ground. Okay, checking this for shorts, and then I'm going to try the first test run, I guess. Okay, here goes the first test run. Let's plug it in and see if it does explode or blow the fuse or anything like that. Okay, let's see. Okay, the LED lights up, which is a good sign. Nothing's humming, nothing's exploding so far. Okay, let's check some voltages. We should have our DC voltage here, which is 19.14 without a load, which is as expected, I guess. I think with a load it will be a bit lower, but still in spec. And the other thing should be the AC voltage, which is 18.9 AC, which is also as expected. So this thing seems to work. That's really good. I like it. I like things that work first try. What's left to do? Make a cable that actually can provide the voltage to the TRS-80 and then put it in the case and try it out. For the cable that is going to go to the computer, I'm using this PVC 4-strand or 4 internal isolated cables. This is meant for AC mains, AC powered lamps that have multiple bulbs, so you can switch them individually and such. And yeah, this is available in most like home improvement stores and things. I think I got this from eBay ages ago. The same wire I used for my Commodore 64 power supply build. Yeah, and for our output, as you can see here, we need 2 AC wires, 1 ground wire and 1 positive DC wire. So this is perfect for the job, and it also has sufficient current carrying capabilities. And also I'm keeping this relatively short. That's like 1 meter or something. And yeah, you shouldn't go much higher than that to keep the cable resistance at a minimum. So I'm just going to strip this. I think I want to drill a hole at first. So this is like 6 millimeters wide. I want to make the hole a bit wider because I want to insert a rubber grommet, which is going to help the cable not to be damaged too much. Like one of these things, they're just there to prevent the cables from the insulation on the cables becoming damaged and things like that. It's just a little rubber ring. There's also much more sophisticated plastic, like cable tie thingies that you can use. I think we would have to drill this hole a lot bigger. Let's just go with an 8 millimeter drill. 8 millimeter drill. Okay, it might work. Let's see if there's a chance we get the cable in there. Wow. Okay. But that's kind of how you want it. You want the cable to not accidentally come out. That's a tight fit. But it works. So I actually took the Dremel to this. Should have built this with single-sided Perfboard because these little pads can be like spark gaps, so you can have arcing of the voltages. I dremeled away some of the pads between the high voltage parts, and I hope that's enough. I hope this is going to work. If you're building this, you should use single-sided Perfboard. It's kind of a design flaw. Also, of course, as you've probably noticed, I'm not a professional at all. So if you want to do something like this, don't trust me with anything. Always do your own research. So the color coding in the cable is going to be completely bonkers. The yellow and green one is going to be our negative, I think. The black one is going to be our DC positive. Yeah, let's do that. So there we go. That should be the power supply side of things. Not the best construction, and yeah, as I said, electrical safety is not a huge thing in this build, so yeah, you should definitely get rid of some of the plating on the Perfboard to have spark gaps that are large enough. So I dremeled away some of the copper below the, at least on the high voltage side, which is the mains power side. 2 millimeters for 200 volts are okay. So 2.54 millimeters, which is the pitch on these, should be sufficient for having enough of a spark gap between the live and neutral wires without the copper between. So you have to remove the copper and then make sure the traces are far enough apart so you don't get spark gaps. Yeah. So we have to build the other end with the DIN plug, which is a 5-pin DIN connector for the TRS-80 power input. So let's tackle that. So quick aside, I actually ended up adding a mains earth connection. I took the whole board out again, added some significant spark gaps between the AC lines so we don't get any arcing. Would indeed be better to have a single-sided board, or now after building this, I kind of would recommend just getting the pre-made circuit boards, which are way easier to work with than to do something like this from scratch. We haven't even tried this yet, so yeah, maybe it's a good idea to just get a pre-made circuit board for this. And yeah, this should actually work. It's not necessary to have this ground connection, but I have the 3-prong connector here, so I'm just adding it. It doesn't hurt, I suppose. If it does, yeah, then I don't know why it should, because that's our potential reference, and it really doesn't matter where the reference is at, I guess. So next step, 5-pin DIN connector, and here's our, yeah, this is the view from the back. The side you actually solder, so not the side you plug into the computer, but the other side where the wires go in. So we have our AC between pins 1 and 3, And we have our DC between pins 2 and 4. 4 is ground, 2 is plus. So that's pretty straightforward, I guess. I hate soldering DIN connectors still, so I bought the best ones I could find, which are Hirschmann, I think. They also have a nice gray color. And these should be pretty easy to work with. I worked with these before, so they are pretty good quality. If I can find them somewhere on the internet, again, I'm just going to put a link in the description. There we go. That should now be a TRS-80 Model 1 power plug. So before I test the power supply, I'm going to actually make a video cable. And that should be a matter of, it's the same kind of DIN connector, 5-pin DIN. Signal is on pin 4 and ground is pin 5. So I'm just using a cut-off RCA jack cable. This is going to be my composite out. It's like from a audio cable, but that doesn't matter much. Let's have another of those 5-pin DIN connectors. So pin 4, so signal pin, which is the center cable here. You want a coaxial cable, and the shield is the actual shield. And you have to be careful to not short out any pins, because there's a 5-volt supply as well that used to be used for an opto-isolator, because the old TRS-80 monitors are basically converted TVs that had a live chassis, which is pretty common for older CRT TVs. And to prevent the risk of shock, they isolated the signal here. So the TRS-80 actually has 3 5-pin DIN sockets on the back side. This one is power. It's really, I don't know what they were thinking. On later computers, they had different pin count DIN sockets, at least, so you couldn't like plug the power into your tape port, which is this one, I think. This is the video, this is tape. Yeah. Okay, let's plug in the video. Very carefully, and we have an on-off switch here as well. Whew. Kind of nervous. Okay, let's plug the power supply in. Turning on the power supply. Okay, we should have power on our power supply now. Let's turn on the actual computer. So nervous yet right now. Okay. No smoke, but we don't get a picture. I think we might have had a picture briefly. Yeah, so we probably have some troubleshooting before us here. So it is the next morning, and actually I did some more work on this off camera because I couldn't really focus anymore. Yesterday worked late and did some more observations on this. I think my power supply is actually working fine, and there's something wrong with the circuitry that is the internal power supply on the mainboard. Let me show you this. Turning my power supply on, which works fine. And oh yeah, it should provide ample voltage. I also used the technical manual that I'm also going to link in the description to find out about the inner workings of the power supply on the board. And it's really good, the technical manual. If you want to learn about how these systems worked, it's just amazing. I printed out the power supply section to work with that. The rest of it, every bit of the system basically is explained in great detail, and it's very, very useful. Also, if you want to troubleshoot other systems, it's really useful because it gives you some excellent information about how these systems work. Yeah, let me show you what we got. So basically, I'm just turning this on. And basically the voltages, there are two voltage regulators, one for the 12 volts and one for the plus 5 volts. That are the important rails. The plus 12 volts are derived from the DC voltage supplied by the power supply. The plus 5 and the minus 5 are derived from the AC that the power supply provides and are rectified and smoothed on the board. The 5 volt being regulated by this regulator. The minus 5 is only regulated by a Zener diode that is in this section here. There's a little rectifier, a full wave bridge rectifier. And the negative portion of this is used for the minus 5, and the positive portion is used for the plus 5, which is regulated in one of these regulators. I think, let me show you the voltages. Should have all our voltages on the RAM. So the thing is, we got our 12 volts and our 5 volts coming through just fine. This is our 12 volts. 12.09. You got plus minus 5% is not a problem. This is our plus 5 supply. So 5.03, it's pretty much spot on. 12.09. And our negative 5 should be supplied on CR2, which is the Zener diode here. And that should be minus 5, and it's minus 3.7. So that's not good. And I think there is something wrong with that circuitry there. Definitely. So we got too little voltage from that Zener diode. That should be spot on. It's a 5.1 volts Zener diode, according to the technical manual, and it should provide 5 volts, pretty much spot on. And it doesn't. It only provides 3.7 volts, so that's a problem. And it might be that the voltage gets pulled, or rather, I wanted to say pulled low, but it's actually pushed high towards the ground because it's a negative voltage. The RAM chips use that voltage. There might be faulty RAM chips. There might be something wrong with the capacitors because they were made in 1978 actually, so they are 42 years old by now. And there might be leakage and stuff like that, and things might be shorting out through a capacitor. I'm not going to get into troubleshooting this in this video because this is already long enough. I think I'm going to make this a two-part video, basically, or this part is building the power supply, which I think is absolutely fine. The rest of the voltages is there, and the voltages provided by the power supply should be sufficient for powering the system. So that was at least a partial success, I guess. got the power supply built. Maybe there's something wrong with the power supply still that I can't see. But I think as far as I've read up on stuff in the technical manual, and as far as I understand the workings of this machine, there should be no problem with the power supply itself. The power supply circuit on the board maybe is faulty. There's too little voltage going in there. So maybe we got a faulty diode or a faulty rectifier or a faulty capacitor or faulty RAM or more faulty stuff. We're going to get into troubleshooting this using the excellent schematics and troubleshooting guides provided in the technical manual in the next episode, I guess. So thank you all for watching. Hope you enjoyed this. Hope this is useful to somebody. As I said previously, if I was to do this again, I would probably go with just getting the PCB for the power supply that Dean Baer designed. And yeah, that's basically the same thing, just easier to manufacture yourself. And given that these systems are so rare, probably worth it just getting something that works and not tinkering with something like I did. But yeah, thanks so much for watching. Hope you stay tuned for more videos on this channel. Hope you stay tuned for the rest of the Tandy people making videos. I'm going to link a playlist of the videos that is going to be updated with the current new videos every time a new video is released in the corner here somewhere, and also in the video description. There's also going to be links to all the channels involved, which I highly recommend subscribing to, as well as, if you haven't done so, subscribing to my channel if you like this stuff. So yeah, thank you so much. I'm Jan Beta. Thanks for watching. See you next time. Bye. And I'm going to troubleshoot this thing now, which you are going to see in the next video. Cliffhanger.